Hi, this is Gary Brooks. Welcome to Orchestrating Health, the podcast where we help you become the conductor of your own healthcare orchestra. I'm incredibly excited today to have Dr. Matt Kaeberlein from Optispan in Seattle with us. Matt, without going into all the detail, it's important for me that people know that you and Dr. Kevin White really catalysts behind this Oklahoma Health and Wellness Summit. It wouldn't have happened without you and Kevin sitting there kind of prodding me and your willingness to come to Oklahoma City. So my hope is in 2040, when Oklahoma City is one of the 10 healthiest cities in the country, that you'll be on stage and be able to at least understand how significant of a part you played in that. So welcome.
Thank you. I appreciate that, and I'm looking forward to that day. It's a very exciting vision you have, and I think you're well on the path to making that a reality.
All right, I want to jump right in. You talk about something that you were the first person I heard talk about this. In fact, I think I had to listen 3 or 4 times before it kind of resonated. Most of us experience healthcare. Something goes wrong, we go to the doctor. I had heart problems, I go to my cardiologist. I ended up getting stents. My wife got cancer, so she goes to the cancer specialist. We treat each disease as if it's its own separate problem. But you're talking about something fundamentally different, an underlying process that you call biological aging that's actually driving all those diseases. So for someone like me who spent his entire adult life treating symptoms, what does that mean?
Yeah, so I think you hit on really one of the core concepts of aging biology and also of what I hope will be the future of healthcare. And so, just take a step back. If you think about the way that we take care of machinery, so automobiles or airplanes, right? We don't wait until the machine breaks to then try to do something about it. We typically try to do preventative maintenance. I think the way our healthcare system is set up, it's much like, being at 35,000 feet in a jet, and then you try to do something about the engine or the wing, right? It just doesn't make any sense. But that's the way that our healthcare system has evolved. And it has evolved that way, I think, for good reasons, because until now, we really haven't had the scientific understanding of what it means to be able to do that preventative maintenance on our own bodies. We largely, not completely, but largely, up until the last couple of decades, have been confined to waiting until disease manifests and then trying to treat the symptoms of the disease. Of course, we'd love to cure diseases, but really most of healthcare is about treating symptoms. Now we have an understanding that aging biology is the driver for most of the chronic diseases that afflict people in developed nations. And we have some understanding of that biology that is allowing us to start to think about ways that we can keep the system working, maybe not optimally, but close to optimally for much longer, so that instead of waiting until people develop the diseases, we delay those diseases until much later in life by targeting aging biology directly. I do want to say, though, that it's not all about aging biology. There are other things we can do as well to keep people healthy. And so I think the exciting part is, we now have an opportunity in healthcare to actually use the science to keep people healthier longer. I think we don't know exactly how long at this point, and that's going to continue to get better as the science improves. But for most Americans, I believe we know enough today to give people 15 years, maybe 20 years of added health span. So I'd call that concept the lost decades, right? Most Americans are giving up 15 to 20 years of healthy life, and we know enough to get that back. So we're really all about helping people reclaim their lost decades, push those diseases of aging, those functional declines back as late in life as we possibly can, so that we can all experience a greater quality of life for 10, 20, maybe 30 more years than we would otherwise.
So is it fair to say that if I'm a cardiologist treating heart disease or I'm treating cancer, I'm adding 2, 3, 4, 5 years to someone's life by treating them? What you're talking about is exponentially larger than that, potentially.
That's right. Yeah. And again, we can put numbers on this. So you're right. At the individual level, obviously it depends on when you get cancer, right? But at the individual level, the gain in life expectancy can actually be pretty big. If we cure somebody's colon cancer when they're 50, they may go on to live to be 80 years old, right? So that's a big chunk for that person. At the population level, though, those numbers are actually pretty small. So demographers have done the math, and it turns out if we could cure every form of cancer, I had a magic pill. I'll give it to you. You take this pill, you will never get cancer. A typical 50-year-old woman gets 3 years of life expectancy across the population. Same thing for heart disease. If we do both, it's about 7 years. And that's because when we treat individual diseases in isolation, all of those other age-related diseases, kidney disease, liver disease, dementia, loss of immune function, those continue to increase exponentially. And so something else is going to get you. Whereas if we can target aging and slow aging, you get a much greater proportional increase in life expectancy, with the added value that those extra years are going to be spent mostly in good health, because we haven't only fixed one thing, we've fixed everything that goes wrong with aging, at least in principle. That's conceptually the rationale for putting more resources into targeting aging, keeping people healthy, than what we have done historically, which is to put our resources into waiting until people get sick and treat sick people. And I do want to add, I'm all for treating sick people, right? I'm not saying we shouldn't try to cure cancer. My mom had colon cancer during COVID, and I am grateful every day that we were able to cure her cancer. I wasn't involved in it, obviously, but her doctors were able to cure her cancer. So, it's really important. We always want to have what I call reactive disease care. We always want to have the hospital systems that can take care of people when they get sick. What I think I'm advocating for, and you as well, is that it would be much better if we could keep people from getting sick for a longer period of time. And there are ways to do that. We have the tools to do that today.
Is this what you would refer to as health span? Those of us who don't live in this health and wellness world, longevity, we hear these terms. A lot of times people don't know what they mean. So lifespan, health span, longevity, right. How do you distinguish between those?
Yeah, it's a great question. So I think lifespan is really easy. That's just the length of time from birth till death. So there's no ambiguity about that. Health span is a good concept. So I'm not going to try to define health span in a quantitative way, but I think conceptually it's the period of life that is spent free from chronic disease with high function in relatively good health. So in some ways, health span is a really great concept, but it's problematic because it's not binary. What I mean by that is you don't go from having 100% health one day to being 0% health the next day. Most people don't. But conceptually, I think we can all can understand there's a period of life where we feel really good, we can do what we want, we don't have any disease. That would be health span. And then there's a period of life most people experience where you have low health, you have one or more chronic diseases, you can't do the things you want to do anymore. Maybe you can't live independently. That's lack of health span, right? That's the period of life, what I would call sick span, where people are sick and not functioning at the level they want to function at. And so the goal, optimally the goal is to increase both, right? And if we slow aging, we do increase both lifespan and health span. But I think for most people, health span is more important. We all want to be able to do the things that we love doing with the people we love and enjoy those things. That's really what health span is all about. We want to maximize that as much as we can for as many people as we can. Longevity is a tough word because that means different things to different people. I think of longevity as encompassing both lifespan and health span. So I put health span, even though definitionally longevity is lifespan, I think at least in the dictionary definition, I think the way the field has sort of adopted it, it encompasses both, right? Longevity is really about living life to the fullest way that we can for as long as we can, and that means both lifespan and health span.
It feels like that longevity word's getting a lot of use out in the marketplace.
Yeah. It's a great word. Unfortunately, it's been co-opted by some bad actors, so it also has some connotations associated with it now that are not, at least through my scientific lens, what I would want to have people think of when they think of longevity. But I think fundamentally it's a great word. It's by and large a great community of people who are all aligned around the principles of giving people as much quality of life as we possibly can. Yes, there are bad actors. Yes, there is snake oil. Yes, there's a lot of consumer-facing products in the space that are not helpful. That's unfortunate, but that's also sort of the nature of the world we live in.
Let me tag on to that because a couple years before I met you, you just became one of my favorite people to watch. I sense this humility with you. Probably three reasons. B, you weren't trying to sell anything on your
Yeah.
podcast. I don't even think I've ever heard you say, hey, follow me and subscribe and hit this. It's just not your deal. But you also put truth out there in a way that resonated with me. So I've heard you called the longevity field's biggest truth teller. I know you're passionate about this field, but why does that gap between what's marketed and what's proven matter so much?
Well, I mean, fundamentally, it matters because it affects people's lives, first of all, right? But it also matters because when there's a gap between reality and what is being marketed, that degrades trust, right? And I mean, I think, you know, unfortunately, we live in a period where that gap feels like it's wider than it's ever been in history, not just in the longevity space, but in general. Like, I think there's a lot of distrust for what historically have been viewed as voices of authority. And I'm not saying there isn't reason for that lack of trust, but I think when that gap exists, trust is lost. And especially when you're talking about a field like aging biology, right? You're starting from a position where you're already working against the snake oil sort of perception, right? And so anything that degrades trust is even more damaging when you're working in a field that has a reputational problem for historical reasons. So that's part of the reason why, especially around the science, I try to be a balanced voice, I hope, of where the science is actually at, what we can reasonably expect in the future, and what is, in my view, an overinterpretation of the science, and what is pure snake oil, right? And I try to give people, and I hope you're right. I mean, I genuinely do feel like there is humility in the way I approach this. First of all, I recognize there's like way more that I don't know than I do know. And honestly, every day I wake up and I'm sort of surprised that I've got a wife, my wife, like this woman who actually is beautiful and she picked me, like, or that people are listening to me. Like I genuinely don't feel like, I feel very lucky. I'm grateful. I'm full of gratitude. Let me put it that way. So I think approaching it from that lens allows me to step back and say, this isn't about me, right? This is, and my opinions are my opinions. And I hopefully say this as well. You shouldn't necessarily trust everything I say. People should try to verify what I say as much as they do everyone else. I just would like more people to try to verify what other people are saying, because there's a lot of stuff out there that's nonsense. And I hear it and I'm like, that's nonsense. Why would anybody believe that? And yet so many people believe the noise and the nonsense in this space. So I'm just trying to provide an alternative voice for people who want, what I think is a more balanced view of reality without being negative, right, all the time. I think there's lots and lots of reasons to be enthusiastic and excited about what's possible, without veering into, the overinterpretation or the snake oil. I guess the last thing I'll say on this is the other reason I think to try to be honest in what's possible today, what's likely to happen in the future is, I think that's a pretty compelling vision. Like I talked about how I believe we know enough today to give the average person 15 to 20 years of health span. That's a big freaking deal, right? like achieving that is really, really valuable and important. But then when you have people out there saying, oh, no, like a child born today is immortal, right? And there are people actually saying that. That creates a situation now where, 20 years doesn't sound like anything, right? So I don't want to diminish what's real and what's possible by giving credibility to, what at best is wild speculation backed by zero data, and what at worst is just self-serving marketing, right? So that's another reason I think to try to be honest, and because we don't want to diminish what's possible, because what's possible is pretty darn spectacular.
Well, there's so much noise out there. I'm a seeker. I'm a person that went from poor health at 60 to learning what health and wellness means. And my goal at the summit was really just to put my orchestra, the people I trust, in front of my friends in my city. Say, You don't have to follow them necessarily, but let me give you the tools that I've used to try to find these people that I can trust. Because as you know, there's just so much noise out there. It's just crazy. I mean, look, think we could go 100 directions. Think about supplements.
Yeah.
My first year, I was listening to people and I was probably taking 40 supplements. Then I heard your good friend Brian Kennedy say, taking 20s like putting 20 colors of paint in a bucket and stirring it up. You just get this brown mixture. And I thought, that's what I'm doing to my body. So I know you've talked about, I think you take vitamin D, omega-3, lithium, and creatine.
Yeah.
So how do you see supplements in your personal health journey?
Right. So again, I think one thing to say is supplements are supplements. They're never going to, and that means they're supplementary to the things that really move the needle, right? Which is by and large lifestyle factors. So first of all, they're never going to make up for a poor lifestyle, right? So that's one thing to appreciate. I sort of think of these as there are big levers or big buckets that have big impact. There are things that are kind of next level down, and then there are things that are truly incremental, right? Most supplements are going to go in the truly incremental bucket. And so when I'm trying personally, this is just for me, when I'm trying personally to evaluate what supplements rise to the level where I think the benefit outweighs the risk or the detriment, right? I think about it as I want to be pretty confident that they're going to provide positive value. I want to be pretty confident that they are going to be safe at the levels that I'm using them in the long run. And I want to know if there are any potential interactions, or at least be able to predict if there are any potential interactions between all of the things I'm doing, including supplements. And that's what I think Brian's getting at, is we don't really have a good understanding of how these different molecules, many of which are truly bioactive, that's why people are taking them as supplements, are going to interact inside our bodies. If I go back to the airplane analogy, right? Imagine you're at 35,000 feet in your private jet, if you're wealthy enough to have a private jet, and you randomly, pull open the panels and start taking wires and moving them around, right? What's the likelihood you're going to make that jet function better? It's pretty low. What's the likelihood you're going to cause it to crash? It's pretty high. It's kind of what we're doing. It's kind of what we're doing if you're randomly taking 100 supplements and you don't know which ones are going to do what. Your body is even more complicated than a jet airplane, and you're just kind of moving stuff around. You don't know what's going to happen. And again, the likelihood you're going to make your body function better, I would argue, is lower than the likelihood you're going to make it function worse. Probably you're not going to make it catastrophically crash, right? But the likelihood you're going to make it worse is probably higher. So that's why I want to minimize the number of different molecules that I'm putting in my body at any one time that all have unknown biological activity, especially when many people are taking supplements at doses that are not physiologically relevant, right? So we're taking them at higher doses than we would normally experience in diet, or if they're endogenous within our own bodies. So that's why I limit the number of supplements I take, as opposed to the other rationale is to say, well, if there's any hint it might be beneficial, I should take it because I might get the benefit. That would be true if there was no potential downside. And I'm simply pointing out one of the potential downsides is these interactions that we don't understand. The other potential downside is there's always impurities, right? And people have probably heard about some of this. There have been some high profile cases where heavy metals have been found in certain brands of supplements or things like that. But every supplement, even when it's manufactured to the highest quality, is going to have impurities around the packaging that goes into the supplement itself, whether it's the capsule or the other inert ingredients. They're called inert. Are they truly inert? Well, at low levels, yes. At high levels, these things can build up in our bodies. And again, we can't necessarily predict what the consequences are going to be. So every supplement you're adding to the mix adds higher levels of these inert ingredients, and sometimes impurities that go along with the manufacturing process. So I just try to appreciate and minimize that when possible. And one way to do that is just to limit the number of supplements you're taking. I don't know what the right number is. And I'm like everybody else, I'm learning as I go. I change my routine based on new information. I wasn't taking lithium a year ago. I've added lithium because I've been convinced that there's enough evidence there that the benefit outweighs the risk for me personally. Other people will come to different risk-reward analyses and calculations, and that's fine. I guess where I would leave people with is you should do that risk-reward calculation and not just assume that if there's any reason that this thing might be beneficial, I should take it.
I sat at a Starbucks here in Oklahoma City with the founder and president of a major supplement company in Chicago. And I was telling him, I said, I take this one and this one that I bought off Amazon. He said, Gary, they weren't ours. I said, no, they're in your packaging. It's exactly, he said, they're not ours.
Yeah.
He said, I've held bottles of supplements that look like we came from our manufacturing plant, and they didn't. Well, that's scary.
Yeah. And again, I think, that points to a larger challenge around the supplement industry in general. And I would argue almost anything in the medical or wellness space that's direct to consumer, right? There's a lack of regulation to begin with, and then there's a lack of enforcement of the existing regulations, which allows for these sort of copycat, again, I would say bad actors in the space who are putting people at risk for profit. But I would also say, most of the wellness direct-to-consumer products, including supplements, even for people who are well-intentioned, the incentive structures in that industry are all pointing towards and forcing people to do things that, at a minimum, skirt what I would consider a line of ethical practice, and in many cases cross that line. I would go out on a limb and say that any supplement manufacturer or marketer, to be more precise, if you look at their marketing language, is deceptively advertising their products. I think every supplement marketer is doing that. I have yet to find one that doesn't. That is unethical by definition. That's not meant with judgment. It's just a statement. And that's because the incentive structures in that industry, in order to be competitive, force companies, individuals to do unethical things. That's part of the reason why I have no interest in going down the path of marketing supplements or marketing direct-to-consumer biological aging tests or things like that, because I think the way that industry works and is set up forces people to go down that path. And so it then falls to the consumer to be able to navigate that landscape of deceptive marketing, sometimes outright fraudulent behavior in the case that you were talking about, where people are mislabeling or copycat labeling other people's products. And it's really, really hard for the consumer to navigate that space right now.
Let's shift to a drug that I know you've taken, I've taken it, rapamycin. Rapamycin, I call you the world's leading expert on it. I'm sure you wouldn't put that label on yourself.
I wouldn't,
but certainly you've spent more time than most people studying this.
I've talked about it more than almost anybody else in the world. How's that?
So, well, I've taken a round of it. I'm going to take more. Talk about where it came from and why you think it's a promising longevity compound.
Sure. So rapamycin is a small molecule. It's produced by a bacterium that's found on Easter Island. So it is actually a natural product for people who, I know some people feel more or less comfortable with things if they come from nature or are synthetic. So it's a natural product. And Easter Island, of course, also goes by the name Rapa Nui. That's where rapamycin gets its name from. And it was originally identified from soil samples on Easter Island and found to have antifungal capacity. So it basically works by inhibiting a protein called mTOR. mTOR is the mechanistic target of rapamycin, so they named the protein after the drug. And when you inhibit mTOR enough, it causes cells to stop dividing. That's its antifungal capacity. So it's a small molecule found in soil that causes cells to slow their cell division and at high enough dose stop dividing. And it does that by inhibiting mTOR. Okay, so why does that matter? Well, mTOR, it turns out, is a central gatekeeper in every I'm going to use the word eukaryotic cell, and that just means anything that's not bacterial. So human cells, dog cells, mouse cells, fungal cells are all eukaryotic, not bacterial. So mTOR is a protein that's essential in every eukaryotic cell, and it basically helps the cell sense the environment and then make the decision, is it appropriate based on the environment to grow and reproduce? And if you think about things in the environment that are important for that decision, this is true at the cellular level, it's true at the animal level, it's true at the human being level. One thing that's really important is how much food is available, because it's a really, really bad idea to have babies if you don't have any food to feed them. So mTOR sort of helps make that decision. It senses the amount of nutrients in the environment. When there's lots of nutrients around, mTOR gets turned up. That's a grow, grow, grow signal. So that's a green light to just go crazy. When there's not very much food around, low nutrients, mTOR gets inhibited, it gets turned down. That's a signal to stop growth and become stress resistant. And rapamycin, as an inhibitor of mTOR, kind of tricks the cell or the organism into thinking there's not very much food around. That turns down growth, promotes stress resistance, and as a byproduct of that low growth, stress resistant state, seems to cause the cell and the entire organism to age more slowly. So what is the evidence that it's actually causing animals to age more slowly? We can give rapamycin to yeast, to worms, to fruit flies, to mice, to rats, even to non-human primates and marmosets, and they live longer. And at the same time that they live longer, pretty much every age-related functional decline and disease that people have tried to measure is delayed. In some cases, you can actually improve function in aged animals. So that's all in laboratory studies. I think that's important to say, but it's been consistent across hundreds of millions, billions of years of evolutionary distance in the organisms where it's been studied. So it gives us at least a reasonable speculation that it probably is going to slow aging in humans or in companion animals. And so that's kind of the point that we're at right now. I don't think anybody who's informed would argue with the statement that rapamycin slows aging, increases lifespan, broadly improves health span metrics in laboratory animals. What we don't know yet is how well is that going to translate to the real world. And so we have some arrows pointing directionally suggesting that it probably does, but we don't know with 100% certainty. What we have are a lot of people like you and me and tens of thousands of others who have been using rapamycin off-label, meaning it's prescribed by a doctor for something other than its FDA-approved indication. That's perfectly legal, by the way. Any FDA-approved drug can be prescribed off-label by any physician, with the hope that it will improve some aspect of health span. And we can get into, if you want to, the various pieces of evidence for different types of conditions where rapamycin seems more or less effective in people. I think where I would sum it for now is to say that rapamycin use off-label seems to be pretty safe. So the side effect profile for healthy people who are using rapamycin off-label seems to be really good. The only side effect that is consistent is mouth sores. About 15% of people will develop canker sores on rapamycin.
I was one of the 15%.
Okay. And you can probably comment then on how much of a problem that was. But it is worth saying the reason why doctors can prescribe rapamycin off-label is because it is FDA approved. It was developed sort of independent of all the aging research that I talked about. Rapamycin was independently developed as an organ transplant drug. And so that's what it got its label indication for. Yeah, this was 25 or so years ago, yes, when it was FDA approved. So that's good and bad, I think. It's good because we have a lot of data on people using rapamycin. It's bad because that's a very unique patient class. These are people who needed an organ transplant for whatever reason, and they're taking strong immunosuppressants at the same time they're taking rapamycin to prevent the organ transplant rejection, and they're taking high doses of rapamycin, higher doses than the people who use rapamycin off-label are taking it at. So we know a lot about rapamycin use in that patient population. We know a lot about the side effect profile, and in that population it does have real side effects. They're not life-threatening, but they're not great. So the organ transplant patients also get mouth sores, but in that case, these are like really nasty ulcerous things in some people. They're not fun. That's probably the patient's biggest complaint and reason why they might stop taking the drug. There's also a higher incidence of hyperlipidemia, so high lipid levels in the blood. Glucose irregularity, something I call pseudo-diabetes, is in a subset of organ transplant patients. Edema, you're worried about infection because these people are taking lots of immunosuppressants to bring down the immune system to prevent the organ rejection. So those are the things that we've been looking for in the off-label use of rapamycin. And I would say in general, maybe there are some hints of slight upticks in bacterial infections, but it hasn't reached the level of statistical significance. So, there might be a small effect, but it really doesn't seem like much of an issue. And there are some things that seem to get better. So I think we're in this really interesting time where, for the people who really know the data, most of us gravitate towards the idea that net, for at least a substantial number of people, rapamycin use off-label has some significant benefits. The side effects seem pretty low. And so we just need more data to be able to understand who's most likely to benefit from rapamycin. Last thing I'll say on rapamycin, because we may talk about some other drugs, the one challenge with rapamycin use off-label is we don't have specific blood-based biomarkers that we can look at to say, okay, for you, we've got the dose right, the biomarker went where we wanted it to go, and we know it's working, right? So it's challenging for that reason, because we don't have a specific biomarker that we can use to titrate and personalize the dose to make sure that it's really working. So there's some guesswork going on for sure in that space.
Well, I didn't notice any on my continuous glucose monitor, but the mouth sores are real. I did back off the dosage a little bit, and it became tolerable. I think what excites me about this is just the idea that this thing was found on an island. The story is fascinating. The guy who found it, I guess, was told not to explore it anymore, put it in his freezer, and 15 years later brought it out.
But smuggled it across the border, all that stuff,
How many other things out there have we not discovered? It's just an incredibly exciting time.
Yeah, and I mean, on that note, one of the things you may have heard me say in the past that the point I try to make is that we understand enough about aging biology to start to take steps to slow aging and improve health span in people. But the fraction of aging biology we understand is tiny. This is the education, or the lesson about the more you learn, the more you understand how little you really know, right? And I think with aging biology, there's so much more to be discovered that we haven't discovered yet. This goes to what you just said. There's so many things out there that we don't know about yet, that there are huge opportunities there. I think one of my frustrations is that very few people are actually looking right now. That's partly because of a resource constraints, and it's partly because of, I think, a lack of innovation in some ways on the scientific side in the field, and that's really due to the way that grants are funded within the system that we've got right now. So all of that's just to say there are real opportunities for, I think, very significant discoveries that can have a larger impact on human health in the future. A lot is left to be discovered when it comes to aging biology.
One of the things that attracted me to you before we met was just your transparency. You seem to be an open book. And I've heard you talk about, you've spent over 25 years in this world full-time studying the science of aging. Yet you hadn't incorporated a lot of the things you were learning into your own lifestyle until later, which is most of us.
Yeah.
I knew before I was 60 things I probably shouldn't be doing that I was doing, and things I should have been doing I wasn't doing. So what was the trigger for you that really forced you to start kind of bringing some of that in? I mean, I've worked out with you. I know how strong you are. And camera doesn't do you justice, my friend.
Yeah.
You're
first of all,
in person.
we got to get in another workout when I'm going to be in Oklahoma in a few weeks. So put that on your calendar. So I mean, I don't think it was one thing, to be honest with you. I think like most of us, we're on a journey, right? And again, and I would say, I mean, I said this before about the supplements. Like, I'm continually learning. I do not for 1 second believe that I've got it figured out when it comes to what I'm doing for my health today. But I'm in a much better place than I was 5 years ago or 10 years ago in that regard. Part of that is knowledge. Part of that is putting it into practice. So I don't know that there was one moment. I think the pandemic was part of it. I think leaving academia, and certainly leaving academia and moving into the role that I'm in now as CEO of OptiSpan. I'm running a healthcare technology company that we have clinical programs where we're seeing clients. I felt that I was obligated both to understand what was best practice in this space and to try to implement it. So that I could learn what worked and what didn't work for me. So that was part of it. I think getting older is just part of it too. You start to notice declines in function. I've told the story before about how the first time I took rapamycin was when I developed adhesive capsulitis or frozen shoulder in my right shoulder, right? So that was a condition where it was extremely painful. But what pushed me to the level of actually doing something about it was when I tried to go across the street to the park with my son and throw a football with him, and I couldn't do the throwing motion. So we all have these experiences as we're getting older where you're like, I'm getting old, right? So I think that was part of it too. So all of that came together, and I'm just so grateful that it did, because that kind of put me on this path of both learning and implementation to get myself to a place where, I'm not going to say that biologically I'm younger than I was when I was 35, but there are aspects of my health and my function, both physically and mentally, where I'm in a much better place now than I was when I was 35. Certainly better than when I was 45. So by the way, I'll be 55 on Sunday, for people who are wondering. So, but it's a journey, and I hope that 5 years from now I'll be in an even better place. And so that's kind of the way I look at it as I'm navigating this healthspan journey and healthspan trajectory.
Well, I'll be 64 next week, so I've got you by a few years.
You do.
60s are the best decade of my life, but
love it.
It does bring on a little more work. So, all right, you mentioned biological age tests. I know you have an opinion about these, and I've heard you talk about these. I get friends going, "Hey, my Oura ring says I'm 6 years younger than I actually am," and I just kind of laugh. I'm like, "Yeah, your Oura ring has no way to determine how old you are, much less these biological age tests." So, talk about that and your fascination with that.
Yeah. So, and I'll say my views on biological aging and biological age tests are evolving as well as I learn more, and I appreciate the way that other people are thinking about this. So, one thing I'll say is I think there are pretty reasonable and sophisticated mathematical ways to think about biological age that can kind of bring together, I think, many of the controversies and confusions that are out there right now. So I'm not going to get into the math. I honestly don't understand it, but I've been doing a little bit of a dive over the last couple of weeks. But what I will say is one component of this is that biological aging, at least as we understand it right now, is not one thing, right? There are many, many, many things that change as we get older, right? And some of those you can just look at cosmetically, right? We can see changes that go along with age that most people or all people experience. Wrinkles, right, would be an example. But there are things that are happening inside our bodies, organ level, tissue level, cellular level, subcellular level, that also are changing with age. So aging is extremely high dimensional, right? There are many, many things that are changing. What these biological age tests try to do is collapse that dimensionality down to one or a few things, and then based on those few things, predict where you're at on that age-related change trajectory. And so let me just give a concrete example. So we know that your risk of dying goes up with age, at least across the population and at the individual level. And mathematically, we can plot that. We can just show, what is the rate at which people are dying as people get older, right? So we can then look at, let's just say, the number of gray hairs on your head, right? And at the population level, we can also make a correlation. Number of gray hairs goes up with age. And then we can look at you individually and say, okay, you've got this many gray hairs. Based on the population level, your biological gray hair clock, it says you have the number of gray hairs of a 55-year-old. Therefore, your biological age is 55 years old. That's what all of these clocks are doing. It's just the things they're measuring aren't gray hair in most cases. Some might be. Sometimes they're epigenetic marks. That's a subcellular DNA level sort of mark. Sometimes they're blood biomarkers. Sometimes you have no idea what they're measuring. They're just making it up. I don't know. For Oura Ring, I presume it's some combination of sleep quality, heart rate variability. Maybe they have blood tests that you've sent them, and they've just kind of made up their own algorithm to tell you a biological age. I'm not saying it's wrong, but it's not scientific. So that's one problem. The last thing I'll say on this is, and by the way, I'm all for biological age estimates in the research world. I think in the research world, especially like the epigenetic clocks, transcriptomic, proteomic, these high biological information types of data, they're really interesting and powerful in the research world. They're telling us interesting things about biological aging. They might, in the not too distant future, be useful in clinical trials as at least secondary endpoints that can be used to provide further evidence that something is affecting health or aging. But in the consumer space, they are a complete mess. And so I think the take-home people should understand with the consumer biological aging clock. So you can go on the internet, you can buy a biological aging test. That's fine if you want to do that. I think it's a waste of money because they are what I would call statistically indefensible, meaning there is no bound where we can say if you get two measurements and they're different from each other, we're confident that they're different from each other. There is no 95% confidence interval that we know of that says if you take a epigenetic test today and you take the same test 6 months from now and your biological age has changed by 10 years, that's a real change. We don't know what that error rate is. So it's just silly for people to think that they can actually get meaningful information from these tests in that way. So I don't think I think it's dishonest the way they've been marketed, and my advice would be just don't bother. Like, it's not worth it. There are things you can do that are informative. Biological age tests are not one of them. Spend your money and your time on things that are informative.
Good advice. One of the things I'm really excited about is having you and your friend, Dr. Brian Kennedy, on stage talking about this lineage 2 biological age clock.
So again, that's an interesting case example where I would say lineage 2. So first of all, this phrase biological age clock is tricky, right? Lineage 2 doesn't measure biological aging. It's a mortality estimator, right? So it's trained on your risk of dying, which is correlated to biological age. I know it gets super complicated, but it doesn't measure biological age. Some people even argue biological age, because it's a multidimensional feature, like I was saying, is what's called a latent variable that can't be measured. So that's a different conversation, but nothing measures biological age today. Lineage 2 is super interesting, though, because the components that are used to estimate your mortality risk are all well-characterized clinical parameters like insulin levels, glucose levels, lipid levels, things that we understand both what the error rate of the measurement is and why those things are connected to mortality in many cases. And what the Lineage 2 test gives you is, I mean, I don't think mortality estimates are all that valuable. Like, how helpful is it for you to know you're going to be 65, but your risk of dying is actually that of a 60-year-old? Like, I guess that's good, but it doesn't really do much. But what Lineage can do for you is it can tell you, and these are the 5 parameters that are driving that mortality prediction. So if we lower your fasting glucose, that will have a positive impact on your mortality risk estimate. And so that's the thing we need to focus on. So that's very different from these epigenetic tests, which, first of all, the number means nothing statistically, but they don't even tell you what to do about it. Whereas Lineage at least gives you some actionable metrics that you can go after to try to reduce your predicted mortality risk. And you'll note I'm being very careful in saying it's your predicted mortality risk. We don't actually know it's your true mortality risk. That's the other thing people need to appreciate with these.
And these are all biomarkers that we should have, our doctors should have on us, or hopefully we do have. So that's exciting.
Yeah, I mean, mostly. So yes, you're right. We all should have them. Most people don't because, again, our reactive disease care system isn't designed to capture the most relevant data on most people. But it's not a heavy lift to get them. So we're not talking thousands of dollars. We're talking, I think in our clinic, we've got a pretty comprehensive blood-based biomarker assessment for our high-tier program, which we call Helix. But then we have a lower-tier program that does a less comprehensive, but what we think of as like the 80-20 of longevity. And that panel has all of the lineage parameters, that plus a urinalysis. It's a couple $100. So it's not, it's not dirt cheap, but it's not out of reach, I think, for most people. And it's certainly not out of reach if we as a society, or let's just say Oklahoma City, made the decision, or Oklahoma State, that everybody is going to get this baseline core set of biomarkers. It's not out of the realm of possibility for that to be affordable, right? I personally believe that if we allocated $5,000 per person to this, we could get those lost decades back. I'm just going to put that out there. That's not an unreasonable amount to spend when you think of what we're spending on health insurance. We will more than recoup that in savings for healthcare costs if we were to do this.
If I could prove to my friends that own businesses that if you'll spend the $200 on all of your employees, you're going to save a lot more than that in insurance costs.
Yeah. Yeah. Well, I mean, the reality is the 200 is just for the numbers. You got to then know what to do with it. But it's a start, right? So that's where I get to the 5,000. I think this is a combination of the lineage, a couple of other core biomarker assessments like body composition. So DEXA, for example, super valuable, right? And then the medical care that goes along with it. That's where we because you got to put the whole package together for people if this is going to be effective. But I would also argue when you look at what companies and employees are paying for healthcare, it's going to be more than that. And so I think there's a reasonable argument that can be made that we should start thinking about this and see if we can get the numbers to pencil out. Other thing I'll say is I think, it's a moving target now to know what's going to happen with the AI tools that are available and how the regulations are going to change around the use of AI in the practice of medicine. That could be a cost piece as well that could make this type of care more widely available at a lower price point.
Well, in OptiSpan, you're bringing all of that care under one umbrella. I want to talk about that, but before, Oklahoma is a big dog state, and I know you're a big dog lover. 44,000 dogs, a clinical trial of rapamycin.
Yeah.
How did you convince the scientific world that our pets are the bridge between lab mice and human longevity?
A shitload of work is how I convinced the scientific world. It was not easy. And I mean, when I say that, let me just be clear. Everybody thought it was a good idea, but nobody thought that we would be able to ever get it funded. And it took a long time. So just give you a little bit of backstory. I mean, so first of all, the Dog Aging Project is what we're talking about here, the scientific study that is actually 54,000 dogs in the United States, and a clinical trial. That was officially started in probably 2014, 2015, but my two colleagues who started it with me, Daniel Promislo and Kate Creevy, were way ahead of the curve. They were thinking about this before I started thinking about it. The idea that you could study aging biology in people's pet dogs and learn important stuff that would be both relevant for the health of the dogs and for the health of the humans. I'd known Daniel for several years. We were co-directing a course at Woods Hole together in 2014 and 2015. And so we spent a lot of time talking about this at that course. It's a 3-week course. You live there, you're working with students, you're just interacting all the time, talking about science. And I'd always been a dog person. I'd had dogs my entire life. Like many people, I consider my pets to be part of my family, love them, to death, dearly. So it was obvious to me why studying aging in dogs was important. But I had this kind of light bulb moment when at that course, after talking with Daniel, where I was thinking, okay, in my lab, we're studying rapamycin and several other interventions that slow aging in mice. The biology of aging is super conserved. Some of these things are going to work in dogs. And then I had this kind of double click moment where I'm like, oh my God, some of these things are going to work in dogs. And I was like, oh my God, my dog could live longer. Oh my God, we could slow aging in dogs. And so when I had that kind of, realization, I was like, I have to do this. And so that for me was when I set out to really start to build what ended up becoming the Dog Aging Project. So to go beyond just studying aging in dogs, which is most of the Dog Aging Project. So most of those 54,000 dogs are an observational study. We're not asking the owners to do anything. We're not giving them any drugs. We're just collecting data to understand the aging process in those dogs. But I was most interested in how do we take what we've learned in the laboratory and use it to increase health span and lifespan of our companion animals. So that's the clinical trial piece that we're now running a large scale, probably the largest veterinary clinical trial in the world, certainly the only one for lifespan, maybe outside of Loyal. I'm not sure how far along they are in their clinical trial, to test whether rapamycin can slow aging in dogs, increase lifespan, and improve health span. So that clinical trial is sized at 580 dogs. It's randomized, double-blind, placebo-controlled. But again, that was 2014 when I started this process. We didn't get the first real NIH grant until the end of 2018. But in those 4 or 5 years, it was all scraping together money wherever I could find it to gather preliminary data to convince the funders to actually support the project. So it was a lot of work to get it off the ground. One of the things I'm most proud of in my life, though, super important, I think there's so much opportunity there, both for what we're going to learn about human aging, but also to improve the quality and quantity of life for our pets, which, it's hard to imagine a more noble cause than that in my book.
If there's ever been a project that a GoFundMe account I could go viral on, that might be it. So
might be. I mean, again, we've always thought that this should be fundable through those kinds of mechanisms. And I will say, we've been successful getting philanthropic funding. I think, like is often the case in philanthropic funding, it's the few big donations that come in that outweigh the many, many small ones. But I agree with you. It seems like the kind of thing lots and lots of people, at least conceptually, could get behind the idea. I do wonder, I think almost everybody who loves their companion animal would be behind the idea of giving $25, $50, $100 to a scientific project that could make that a reality. I do wonder if people just have a hard time believing, right, that this is a possibility. I don't know why it hasn't been. We haven't been more successful at raising funds. I will say, though, for anybody, shameless plug, for anybody who's interested in donating to the project, we have set up a 501c3 nonprofit. It's called the Dog Aging Institute. dogaginginstitute.org. Please, I would be grateful if you go there and support the project with your donation.
Yeah, I'll push it even more. Okay, Oklahomans, for those of us who love dogs, and those of you out there who are good at this kind of stuff, let's get a GoFundMe and start moving this hard for Matt. Hey, let's talk about OptiSpan. I'm fascinated by what you've done. Talk about when you started it, how it's different than what most of us would see as a traditional doctor's visit.
Sure. Yeah. So OptiSpan really sprang out of a series of conversations that I had with a man named Dave Saby. Dave is pretty well known in the data center world. So he owns a company called Saby Corporation, which is, I think, the largest privately held data center company in the world. But Dave has had a long-standing interest in healthcare, has long been frustrated with many of the inefficiencies and problems that we've already sort of talked about in the existing healthcare system. Also had a long-term relationship with a pretty famous scientist named Lee Hood. Lee is really well known in the systems biology world. He was at the University of Washington, then started something called the Institute for Systems Biology here in Seattle. Also has sort of dabbled in the wellness space, and I think one of Lee's fundamental contributions to the health and wellness space is pushing forward the idea that if we knew what the right biomarkers were to measure and we had sufficient depth of coverage, that we would be able to detect dysfunction, drift, disease before it becomes pathological and put people onto a trajectory that allows them to avoid those dysfunctions and diseases. Lee hasn't really looked at it until at least fairly recently through the lens of aging biology, but he was thinking along these lines, that we could detect drift and we could move people onto a better trajectory. So through a series of conversations with Dave, we realized we were sort of aligned on wanting to do something around healthcare that would allow us to positively impact the health of people at scale. And that's the concept behind OptiSpan. The reality behind OptiSpan has been, that's a great idea. How do you actually do it? And how do you run a business doing it, right? So we're first and foremost a healthcare technology company. Our goal is to create technologies that enable scalable, proactive healthspan medicine for as many people as possible. As part of that, I felt from the very beginning that we needed to run our own clinical operations for me in order to understand what works, what doesn't work, where are the friction points, what can we develop solutions to bypass, what are some friction points in the regulatory or healthcare environment that we're just going to have to live with. We have to figure out how to ameliorate them to the point where we can be successful in our sort of overarching mission. So we started, I think we spun out September of 2024. I'm showing my age. Maybe it was September of 2023. So it's been a couple of years now. Our first goal was to set up the clinical program. And so we've been really, I think, quite successful at doing that. We've got like I mentioned, a full service out-of-pocket concierge care program, I would, I'm biased. I would say we are on par with the best of the best in the world when it comes to concierge longevity medicine or healthspan medicine, whatever you want to call it. Honestly, most of these programs have an overlapping set of diagnostics, somewhat different philosophies on how you interpret the diagnostics and enable behavior change and provide medical care to people. I think we've got it down as well or better than anybody else in the space. So we have that program. We call it Helix. And we have a couple of other programs. The one that I think is closest to the scalable model, and this is where I get that sort of 5,000 number, is a program that we so far have been working internally as a corporate healthcare program. So we are providing the corporate healthcare program for Sabi Corporation. That is what I think of as the longevity 80-20, right? And if people aren't familiar with that idea, get 80% of the value for 20% of the work or 20% of the cost. I think we all recognize that you don't need to spend $100,000 on diagnostics in order to get the majority of the value. What I didn't know going in is what it would take to get that 80-20. I think I've got, and again, I'm absolutely going to say this will change in the next year for sure. I'm still learning, but I think we're closer. We're close. So that's where I get that $5,000 number from, where I think that's about the 80-20 right now, given the technology that's available, the diagnostics that are available, and what it costs to give almost everybody most of the benefit that we can extract right now. Obviously, it's individual. It depends on people's willingness to lean in, right? There is some lifestyle component, I'm not going to lie. But I think we can do that. So that's our corporate program. And that's what I think we have the opportunity to scale and make available to a much larger number of people. And this is where I think whether it's us or someone else, I mean, again, this space of companies that are working in longevity, direct to consumer apps, selling blood tests to people, high-end concierge medicine. It's a super interesting, churning space, lots of really smart, cool people working in it. We're going to get there as a community. I would love, obviously, for OptiSpan to be part of this, the success story. I think we will be, but somebody's going to figure this out. And I think if we can get buy-in from large employers or, again, even more successfully, government agencies to do this at scale, there's a real opportunity to bring this type of healthcare to more people. Again, it's not going to replace the existing hospital system. I think it could be what primary care morphs into, what primary care could be. And I think these AI tools provide the potential, we're not there yet, but they provide the potential to really help diminish some of the healthcare disparities that are out there right now, right? I'm not at all going to pretend that everybody listening to this can afford to spend $5,000 on their healthcare. I think most people listening to this probably could. That's a different conversation, like where we as individuals invest our resources for our own health. I think part of this is people should get really comfortable with the idea that your health is your most important asset and you should invest your resources appropriately. That's a different conversation, and there are definitely people who don't have that financial buffer to be able to take $5,000 and put it towards their health. I think the AI tools can help there to bring a better level of healthcare, even to people who don't have the resources to invest at that level. So I'm as you can probably tell, I'm excited. I'm really optimistic. I am sort of frustrated at how long this takes and how slow it goes, but I think there's real opportunities to help a lot of people. And again, I am just super personally grateful that I've been on this journey because it's helped me personally, and it's helped some of the people I love. And so it's been a lot of fun, and I'm optimistic about the future.
Well, I'm a believer in AI becoming the great equalizer in this health world. In fact, we'll have a keynote. Our final keynote on Tuesday is on that topic, specifically
Great.
AI. I'll talk about how I use it in my own personal journey. I'll bring a Faraz Garfe, a friend, expert in on that issue, talking about technology and AI. So I probably should have said this to you privately instead of publicly, but I have an ulterior motive.
I'm an open book, so don't worry about it. Sorry, what'd you say?
I have an ulterior motive to bring OptiSpan to Oklahoma. So the more I can integrate you into our city and our state, the better. I love what you're doing, and I think Oklahoma would be a perfect fit for that if that's something that would work for you and your business partner someday.
We'll make it work. Again, I think somebody, again, at the city or county or state level, like somebody's going to be the first to do this, right? Why not Oklahoma?
That's what I say. Why not us? So there's a lot of noise in this longevity world around biohacking and protocols that are really expensive. But one of my goals is to make Oklahoma City one of the healthiest cities in the country and making healthy aging available to everyone, regardless of their economic or social status.
Yeah.
How do you see that science of aging being open more and more to the general population?
Yeah. So again, there's a couple things I would say to this. We've already touched on how the AI tools have the opportunity to level the playing field when it comes to healthcare disparities, at least a bit, right? Certainly, I think pretty significantly. What does that look like? How does that work? I mean, I think the most obvious way is that right now the cost of the big cost drivers are the diagnostics and the medical professional time, right? I think the AI tools are really pretty good at integrating the diagnostic data and giving at least preliminary interpretations and recommendations. I'm not suggesting at all we want to take the doctors out of the loop, but I think we can greatly cut down on the time, the physician time, that is required to provide a primary care experience that is an order of magnitude better than what we've got today using these AI tools. So less physician time, better experience. That's a cost saver, and that helps with the disparities. And these AI tools are not super expensive to roll out to the population, right? So that's one way. I think the AI tools themselves also can play a big role around behavior modification. And this is a little bit more speculative because nobody has really figured out behavior modification, period, right? Let alone how to use AI to do that. But, we have a coaching component to our programs. I think coaching can be quite powerful when done well. And I think the AI tools can adopt some of the coaching approaches that are most effective, and in many ways can improve upon the use of human coaches because you can get access to them 24/7 when you need them. And for people who are comfortable with wearables, they can actually give you coaching in real time when you need it most based on some of your biomarkers. So again, that's in the future. It's not ready yet, but it's a pretty easy path to see how these tools can mature to that point where they can start to fill that void, help with behavior modification. And I do wonder, I know for myself, I think a lot of people are this way. 10 years ago, I think I probably was close to being ready to go on this journey, but I didn't know how. And I think if I had a tool that told me exactly what to do, I probably would have done it back then. So I think that's also where these AI tools can be very effective because we know enough now to get to somewhat personalized lifestyle plans. We give a health optimization plan to every OptiSpan client that is personalized to them. Sure, a lot of the recommendations are general for other people as well, but we personalize it for every person. And I think these AI tools are there. They can do that now. And so if we can give people who want it very, very detailed plans, diet plan, exercise plan, sleep plan, even relationship plans if you need that, right? Hey, did you remember to call your, aunt this week, right? Stuff like that. I think we can help people who are ready, who just don't know what to do, and they don't have the time to figure out what to do, right? So that's another way where I think these tools can be quite valuable. Now, you asked about aging in particular. I think that's a different story, right? So how do we target aging biology outside of lifestyle? How do we target aging biology effectively? I want to double click on that comment though, because I think people should appreciate lifestyle is targeting aging biology. There's a reason why healthy diet, regular exercise, getting good sleep, human relationships affect not just one age-related disease, but all of them. It's because you're affecting your aging biology by the way you live. So estimates differ, but somewhere between 50 and 80% of your longevity is determined by your environment, and most of that is your lifestyle. So you're having a big impact on how fast you're aging by the way you live. I'll just leave it at that. But once we get outside of that, There are a few drugs that I think we can make a pretty compelling case also probably modulate aging biology. We talked about rapamycin. We haven't talked about SGLT2 inhibitors, haven't talked about GLP-1 agonists. There's a handful that I think we can make a case could also be modulating aging biology and certainly can be used in a proactive, preventative way to keep people healthier longer. And then supplements are the other bucket that we can think about. Core set of supplements, somewhat personalized, that can be used in a proactive way to help support a better health span trajectory. And again, I think the AI tools can help with that personalized recommendation. Again, I'm not ready to say we want to take the doctor out of the loop. I think we still want a trained doctor to be able to look at what the AI is recommending, tweak it, give that personal human touch. I think the human piece is still important here. Maybe that's the last piece I'll end on. I think one thing that we don't have right now is a generation of doctors who are trained in this kind of medicine. There are a lot of doctors who are interested, which is great, but that's going to be a piece as well, getting doctors who want to do this kind of healthcare up to speed on what that actually looks like and what that means. That's another part of our, grand plan at OptiSpan is to create a playbook, right? A clinic and a kit maybe, where for doctors who really want to go with what's best in class right now, here's our best in class approach. You don't have to do everything the same way. Here's what we do. Here's what we would recommend.
Yeah, one of the things that I like to say on orchestrating health here is that we want to help you become a partner with your doctor. AI is not going to replace your physician, but how can we help you become a better partner?
Yeah.
Well, as you know, I can ask you questions for hours, but I need to kind of wind it down because you've got work to do. But I am interested in your connection with Oklahoma Medical Research Foundation. You made a comment to me that some of the best aging research in the country is happening right here in my city. And so I've got very familiar with them, but just talk a little bit about OMRF and what's happening here in Oklahoma City.
Yeah, so OMRF and the University of Oklahoma have, one of the top cohorts of aging scientists in the world, and they have for many years. And many of them are good friends of mine, so I'm a little bit biased there as well, but I think they're both great people and great scientists working on diverse aspects of aging biology. So it's not like everybody there is only working on, say, mitochondrial function. So Ben Miller, of course, who's going to be at the conference, fantastic guy, fantastic scientist. His research on, the impact of exercise and muscle biology on aging, I think has been really impactful. Veronica Galvin, who has done some of the best work in the field on the overlap between dementia and biology of aging, particularly the effects of rapamycin on Alzheimer's disease and other dementias using both animal models and supporting some human clinical trials is fantastic. Arlen Richardson, who's going to be at the conference, a mentor of mine from many years back, one of my all-time favorite people in the field. So Arlen Richardson and George Martin are two people I would point to. George unfortunately passed a few years ago, who had a big impact on me, not just because of their science, but just because they're just like fantastic human beings who support the field and support younger scientists and support people. So Holly Van Remmen, who worked with Arlen for many years, is there as well. So there's just a whole group of people who, like I said, are both really great human beings and top scientists doing top work in the field, who also have had a big impact on the field because of their service. So I think all four of those people who I mentioned were leaders in the American Aging Association at one point or another, which is the largest academic society focused on the basic biology and translational biology of aging. So they have contributed to the field both through their scientific discoveries, but also their service to this organization that, broadly speaking, supports the science of longevity in the United States and around the world.
Yeah, well, this is our first Oklahoma Health and Wellness Summit. This is going to be an annual thing. We hope to grow it very large and expand it through the state. I really wanted it anchored in science, which is why I've got you and Dr. Kennedy and Arlen and just OMRF involvement. It was important to me because, as you well know, you get into this health and wellness world, you can go 1,000 directions and it can get really edgy really quick. And I didn't want that. Not that we want to ignore all of that, but it was important to me to anchor this in science to just really be credible.
Yeah, and I think one thought I would add to that is that it's not always clear where the gray area begins and where it ends. I think it may be helpful for people to appreciate that in both science and medicine, we're often talking about probabilities, right? We have models for what we think is reality, but they're models. They're imperfect. They're the best model we can build based on the data that we've got. Models need to change. So I think sometimes people get confused when, there's a scientific recommendation to do one thing, and then 5 years later, that recommendation changes. That's not a bad thing. That's what's supposed to happen. Science is creating the best models we have that fit the data to explain reality, but they're imperfect. And science is about figuring out where those models are imperfect, and sometimes that means we have to change our recommendations. Another implication of that, though, is we never have 100% certainty about almost anything. There are a few things that approach it. Like I think we know, with a pretty high degree of certainty that eating a salad for lunch is better than eating French fries. But there aren't a lot of things that approach that 100% level of certainty. So like when you and I were talking about rapamycin, sure, I could put a percentage on, what do I think is the percentage rapamycin is positively benefiting my health? But it's a guess. It's a guess based on knowledge, but it's still a guess. And so there's a lot of stuff in this space that is just a degrees of confidence. And where you cross that line from, pretty high degree of confidence to pretty speculative to completely unsupported by data just isn't always clear. So I try to be careful when we're talking about that, not to immediately lump people in with the snake oil side. There are people who are doing snake oil, who are being intentionally dishonest. But I think there's a lot of gray area that I don't know. I don't know what the right answer is. And we shouldn't pretend that we do. Each person has to be comfortable with what their comfort level is with uncertainty for what they're doing for themselves, right? And I think that's where some biohackers have become very comfortable with doing stuff that have a high degree of uncertainty. My key distinction, though, is I think it's important for people to be informed about what the risks and rewards are in making those decisions. So again, I said that before. That's one piece of advice I just reemphasize is when you're thinking about these things for your own health, try to become informed. Don't accept it just because, Liver King said I should do this on a YouTube video. Don't accept it just because a doctor who you really like says this is what you should do. Do your homework and try to become informed for yourself about, whatever decision you're thinking of implementing for your health or not implementing.
Well, that's part of the goal here of orchestrating health is hopefully we can become a louder and louder voice for not only the importance of science, but we just have to keep funding it. We have to keep funding good quality science. We cannot stop this.
Yeah.
Well, on Tuesday, March the 10th at noon, Mayor David Holt and I, along with senior leadership at the Oklahoma State Department of Health and the Oklahoma County Health Department, will roll out our 14-year initiative to move Oklahoma City from one of the least healthy cities in the country to one of the healthiest. So Matt, as someone who spent your career studying what actually moves the needle on human health at scale, what would you tell a city that's about to take on that kind of challenge?
Well, first of all, I would say it's possible. Like, don't get bogged down in the idea that this is an unsolvable problem. It's a solvable problem. I think engaging with voices who are thoughtful and credible in the space is going to be super important as you really try to think about how do you implement programs that are actually going to be successful at the population level. But it is doable. And then at the individual level, I would go back to what I said before, which is to recognize that your health is your greatest asset. And so start thinking about, have you been investing in your health? Should you be investing in your health? Obviously, I think the answer is yes. And then what does that mean? What do you actually do to invest in your health? I think that's the start of the journey. And then you can start to become informed and identify for you personally, what are the biggest steps that you can take to get yourself onto the best health span trajectory that you can be on. And you can do it. I did it. I know. It's not too late. So I hope some of the people listening, if you haven't already started, that this will be an inspiration to you to start that process and put yourself 10 years from now, 5 years from now, in a better health trajectory than you're on today.
Well, Matt, thank you. You've been an incredibly important voice in my world, even before I met you. And I can't wait to expose my friends to you, to get to meet you, and hopefully you'll have the same kind of influence on them. And my goal someday is that Oklahoma can influence you and OptiSpan, and we can become part of your family, just like folks up in Seattle. So I'm extremely grateful for your friendship and for your willingness to invest in our city. And any other comments you have for our listeners?
No, just I want to thank you as well, Gary. I'm grateful that I've gotten to know you, and I'm inspired by the efforts that you're putting in for Oklahoma City. So I'm really looking forward to being out there in a couple of weeks, and I'm super excited about what we can do together.
All right, go to healthycityinitiative.com. We've got room for about 420 folks at the Skirvin, March 9th and 10th. We would love to see you there. And on behalf of Orchestrating Health, have a great day.